Welcome to Miss Taylor's class notes, and today we're going to be talking about quadratic functions. So, when we look at quadratic functions, here are examples of quadratics, and here are not quadratics. So real quick, I want you to just look at these two sets of examples, see what do our quadratics have in common, and then I want you to compare them to what they are not. And then I want you to answer this question here. So go ahead and pause the video and do that now. All right, so what you should have figured out about quadratic functions is that they have a degree of 2. And remember, degree means the highest exponent. So for it to be a quadratic function, it has to have an x squared, and the x squared has to be the biggest exponent. So our standard form of quadratics, we use f of x, but remember f of x is the same thing as y. Ax squared plus bx plus c. So you've been factoring quadratics for a couple of weeks now, and now we're going to look at what quadratics actually are. So the graphs of our quadratic functions, we call them parabolas. Again, not parabolas, parabolas. So what we're going to do right now is we're going to open up Desmos, and we are going to graph this function here. F of x equals x squared minus 2. Remember, we can turn this into a table by hitting our settings and then by hitting our table. So -2 is 2, -1 is -1, 0 is -2, 1 is -1, and 2 is 2. We also could have figured this out by plugging them into our function up here. So if we were to put -2 in the x spot, we would have had -2 squared minus 2, which is how we got to 2. Just remember, you can do it either way. So now we need to graph these. So I'm going to start with -2, 2, -1, -1, 0, -2, 1, -1, and then 2, 2. And then I'm going to keep drawing my graph up. And so this is what we mean by a parabola. Our parabola has a U shape. So our A value, remember we said our standard form is y equals ax squared plus bx plus c. We've also been using these when we were doing factoring. So our a is the number in front of x squared, and we always have an invisible one if there's not a number. If we notice there's no bx term, so our b is going to be 0 because it disappeared, and then our c is going to be -2. So we're going to do the same thing here. We're going to graph this in Desmos. So if we notice, the only thing that's different is that our a here is a -1. So I'm going to go ahead and put a negative in front of my x squared, and then I'm going to turn it into a table. So our 2 is -6, 1 is -3, 0, -2, 1, -3, and 2, -6. So we've already said that our a value we know is a -1. There is no b value, and our c is -2. So now it's time for us to graph this. -2, -6, -1, -3, 0, -2, 1, -3, and then 0, or 2, -6. And then this parabola, you notice, opens down instead of opens up. Opens down. I also like to think of it as a frowny face. Whereas our other one opened up, and I like to think of it as a smiley face. So let's do one more. Again, we're going to go Desmos. We're going to graph this. Y equals x squared plus 2x minus 3. I'm going to hit settings, turn it into a table. So when I do things like this, I like to look at the values that are going to help me graph it. Okay, so those values are going to work pretty good. So -2, -3, -1, -4, 0, negative 3, 1, 0, and then 2, 5. Negative 2, negative 3, negative 1, negative 4, 0, negative 3, 1, 0, and then 2, 5. So our parabola should look something like this. And again, it's a smiley face. It opens up. Our a is our value in front of x squared. Our b is our value in front of x. And our c is our value without an x at all. So if we look at our a values, so the first one we had an a value of 1, the second one we had an a value of negative 1, and the third one we had a value of 1. So when a is positive, it's going to open up or have a smiley face, because the a value is positive, and when you're positive, you're smiling and you're having a good day. If our a value is negative, it's going to open down or have a frowny face. Again, if it's negative, things are going bad, it's not a good day, and so typically we've got a frowny face. That's the easiest way for me to remember that. Positive a is up, negative a is down. So next, we're going to talk about some key vocab around our quadratics. So the first thing that we're going to talk about is we're going to talk about our vertex. Our vertex is the maximum or the minimum points of the parabola. So if it's a maximum, that means it's going to be the highest point. If it's a minimum, that means it's going to be the lowest point. So if we come and we look at our graph here, our vertex is going to be, again, the very bottom or the very top. And so that's our vertex right there. So now let's talk a little bit more about maximum or minimum. So the maximum or minimum is always going to be the y value of the vertex. So, and remember, maximum is going to be our frowny face because it's going to open down because that's the highest that it's going to be. Whereas a minimum, it's going to open up, it's going to be positive, and that's going to be at the smallest point. So our maximum is a negative a, our minimum is a positive a. So if we look at this graph here, our vertex is at the very bottom, so that means it's a minimum graph. Let's go ahead and do this real quick. So our vertex, if we're reading the graph, 1, 2, 3, 1, 2, 3, 4 would be 3, negative 4, which means our minimum value would be negative 4. All right, zeros. We have 4 names that all mean the same thing. The first name that we're going to talk about is zeros. So the zeros is the point where the parabola crosses the x-axis. We also, our second name for them are solutions. Our third name for them are roots. And then our fourth name for them are x-intercepts. This is kind of one of these things you're going to have to commit to memory. Zeros, solutions, roots, x-intercepts. So if we go and we look at our graph, again, x-intercepts is our key. It's going to be where it crosses the x-axis. So our zeros, our roots, our solutions, and then our x-intercepts. And so this root, this zero, this solution is 1, 0. And we're going to write it all down again just to help us remember. So zeros, roots, solutions, and then finally x-intercepts. And this one's going to be 1, 2, 3, 4, 5, 6, 0. So last thing we're going to talk about, you already know all about y-intercepts. Y-intercepts is where it crosses the y-axis. So our y-intercept is at 1, 2, 3, 4, 5, is at 0, 5. So real quick, let's just go over a couple of these together to make sure we understand. Again, vertex is the highest or lowest point. So it's going to be at 3, -4. If it's a maximum, that's the highest point. If it's a minimum, it's the lowest point. So the bottom of the parabola is going to be our min, and our minimum value is the y point of the vertex. Our zeros are going to be where it crosses our x-axis. We typically have 2 zeros per graph. Occasionally we'll have 1, occasionally we'll have none. So one of our zeros is at 1 and at 5, and then finally our y-intercept is at 0, 5. So again, vertex is the highest or the lowest point. In this case, it's the highest, and it's going to be 0, 3, 4, 5, 6. Because it's the highest point, that makes it a max, and so our maximum value comes from the y value of the vertex, which is 6. Our zeros, which is where it crosses the graph, are -4 and 4. And then finally, our y-intercept happens to be the same as our vertex, 0, 6. And so now let's find our vertex. It is -4, 0. It is the very bottom, so it means it's a minimum, and our minimum value is 0. Because again, we're looking at the y point of the vertex. Our x-intercept, in this case, we only have one x-intercept, and it happens to be our vertex. And then our y-intercept appears to be 14. All right, I want you to answer these next two on your own, and I want you to check with the completed class notes.